In this lecture, we're going to talk about two more integration techniques, which are integration by partial fractions, and integration by trigonometric substitution, So, let me first do the example here. If I want to find the integral of 1 over x minus 2, I can use the u substitution to deal with this. I'm just going to let my u be the denominator here. So my u is going to be x minus 2 and my du is going to be just dx. So my integral here becomes the integral of, this is just going to be the integral of 1 over u du. So that's just going to be log of absolute value of u plus c. Now I can plug u back in, so that's going to be just the log of absolute value of x minus 2 plus c. Okay, so not too bad. Let's do the next one. If I want to integrate 2 over 3x minus 5, well, I can do the same thing. I'm just going to let my u be the denominator here. So my u is 3x minus 5, so my du is going to be just 3 dx. If I move my 3 to the other side, my dx is just going to be 1/3 du. So my integral now becomes the integral of 1 over u, 2 over u, let me do 2 over u, times dx, which is 1/3 du. So 1/3 du. Now I can pull the constant, which is 2/3 out, so that's going to be just 2/3 times the integral of 1 over u du. Once again, the integral of 1 over u is just going to be log of u, log of absolute value of u. So the answer for this one is going to be 2/3 times log of, 3x minus 5 is the absolute value plus c. Okay, so let's do my next one. Now for part C, this is a little trickier because if I try to use the u substitution, if I let my u equal to the denominator here, 3x squared minus 11x plus 10, then my du would be 6x minus 11 dx. And I don't see 6x minus 11 anywhere. And 5x plus 9 doesn't look anything like 6x plus 11 either. If I try to use the integration by parts, so I'm going to need to write this thing as the integral of u dv, u times dv. And it doesn't look like I can let anything be u and dv where I can find u and v easily either. So these two methods that we have earlier certainly doesn't work on this integration. So let me actually just go ahead and tell you how we're going to deal with this. It turns out that the thing in the integral here, 5x plus 9 over 3x squared minus 11x plus 10, this thing is actually just equal to 1 over x minus 2 plus 2 over 3x minus 5. So it's the two things that we have earlier. To check this, if I add these two things, so let's see. If I add the two fractions here, for the denominator, I multiply these two things, so that's going to be 3x squared. The middle term is going to be negative 5x, and then negative 6x, and then plus 10. So that's 3x squared minus 11x plus 10 in the denominator, so that's the same thing that we see here. For the numerator, I cross multiply, so that's going to be 3x minus 5 times 1, so that's going to be 3x minus 5. Plus, I multiply x minus 2 by 2, so that's going to be 2x minus 4. Once I add these two things, that's going to be 5x minus 9. So that's what we see here. So it turns out that this integral is just going to be the same as the integral of 1 over x minus 2 dx minus the integral of 2 over 3x minus 5 dx. So I can basically just subtract the two answers that we have earlier. So that's going to be log of absolute value of x minus 2 minus 2/3 of log of absolute value of 3x minus 5 plus c. Notice how the plus c and plus c here is not gonna actually just cancel out, because once again, this plus c, it represents a number. It can just be any number. So this plus c, it just means that the integral of this function is gonna be log of absolute value of x minus 2 plus any number. This can be any number, so when you subtract them, it will just be any number. So that's what this plus c actually represents. So that's how we can find the answer for part C. But the problem is, well, suppose that if we haven't done part A and part B earlier, how are we supposed to know that the integral in part C can be written like this? And we're going to talk about this in the next example.